Okay, folks, so we're going to look at this problem here where it's asking you to factor this polynomial fully. Now this is going to be an easy one because you'll notice up here the leading coefficient's a 1, and so really what that means is our goal here is to factor this because this is a 4th degree polynomial. We want to factor it to give us x, and then some numbers inside those brackets with x. And the reason we know that is because there's a 1 up front here, so in order to multiply and get 1x to the 4, these coefficients inside all have to be the number 1. So then we're also going to look at this last number because the product of these numbers here in green have to give positive 12. So what we're going to do is we're going to utilize the factor theorem, which remember is f at a. If f at a equals 0, then x minus a is a factor. So we're going to check and see for different values of a, is the remainder 0. So the numbers we're going to check are based on that positive 12. So we're going to look at the factors of positive 12, which are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, and plus or minus 6, or plus or minus 12. But we're not going to have to use all of them. We're going to use the ones that work, and we're going to start with the smaller numbers first usually. So f at 1, we'll try first, and that's going to be 1 to the 4 plus 1 to the 3 minus 13 times 1 squared minus 1 plus 12. So that's going to give us 2 minus 13 plus 11, which equals 0. So look at that. We've already found one that works. So since f at 1 equals 0, then x minus 1 is a factor. Okay, so then we can basically start up here and say, well, that's x minus 1. That works. And now what we're going to have to do is the synthetic division to see what's left over when we factor that out. Okay, so when we factor that out, we're going to have a coefficient of 1, 1, negative 13, negative 1, and 12. And we're putting in 1 here because that's what we put in right there. So drop the 1, you get 1. 1 times 1 is 1. Add those up, you get 2. 1 times 2 is 2. Add those up, negative 11. 1 times negative 11 is negative 11. Add those up, negative 12. 1 times negative 12 is negative 12. You add those up vertically, you get 0. That's our remainder. So here now you have a constant term, you have an x term, you have an x squared term, and an x cubed term. So now, this basically factors to x minus 1 times x cubed plus 2x squared minus 11x minus 12. So now our new question becomes, how do we factor this? Right, so now it's a cubic function. We're going to perform the exact same thing. So I'm just going to have to keep zooming out a little bit, just so you can see all the work that I am doing. But I'm going to move this up slightly. So our new question is factoring this. So we've already used f at 1, which means that's probably not going to factor again. So what we can do, though, is we can look at, let's say, f at negative 1. So let's try that one, because that might go out. So negative 1 cubed plus 2 times negative 1 squared minus 11 times negative 1 minus 12. We end up getting negative 1 plus 2 plus 11, not 12, minus 12, and that would be, when you get negative 1 plus 11, or sorry, 1 plus 11 is 12, minus 12. Oh, look at that. That works too. So now that means since f at negative 1 equals 0, x plus 1 is a factor. Now remember, it's really x minus negative 1, which becomes x plus 1. So now, if we go back up to the top here, x plus 1 is a factor as well, which means now what I can do is I'm able to do the synthetic division for that polynomial as well. So I'm just going to do that over here, where the coefficients were 1, 2, negative 11, negative 12, and I'm going to put in negative 1 here. because again, that's what this value is. So drop the 1, 1 times negative 1, add those up vertically, multiply by negative 1, add those vertically, multiply that, add them vertically, you get a 0 remainder, which is good. And then that's our constant term, that's our x term, that's our x squared term. So now when we factor this, we get x minus, we get x minus 1, which is the original bracket. We get x plus 1, and then we're left over with x squared plus x minus 12. And then here now, because this is just a quadratic, right? Because this is quadratic, we can just factor this using simple product and sum. And this should factor here to give us x minus 3, x plus 4. Okay? So if you don't know your quadratics, you need to be able to factor those just so that you don't have to go through the factor theorem again. But this here ends up being our final answer. Okay, so our very final answer here, if we're factoring that polynomial fully up at the top, is that. Now this is an easy case for a degree 4 polynomial because the coefficient on the x term, or the x to the 4 term, was equal to 1. Okay, now that might be slightly more difficult, as I'll show in the next video.